mean, you can think about a cell as a system. And so tissues are just systems of systems, a system of systems. And so you want to try to understand the differences between cells and even the differences between the same type of cells, because they're reacting to their local environment and things that are going on locally. And so we want to try to understand all of that. The field of proteomics mostly focuses on digesting proteins to peptides. And part of the rationale for that is that the technologies to analyze peptides is more mature and more robust. The technology to analyze proteins is not as robust, and proteins are actually much harder because the chemistry of proteins is more diverse, more extreme. There's a big difference between membrane proteins and which are very hydrophobic and very difficult to deal with, and proteins like mucins, which are very, very heavily glycosylated. And so dealing with intact proteins, there are many more challenges that you have to deal with. And so that makes top-down proteomics has lagged bottom-up proteomics in its ability to really address important biological questions. One of the strengths of top-down proteomics that really drives the field is the ability to look at what we call proteoforms. And proteoforms are nothing more than differently modified proteins that come from the same gene. So a gene can be spliced and create proteins of different sizes and so forth, and then they can be differentially modified depending on what function they might have. And so one of the key elements of top-down proteomics is to try to define how is the function changed by various modifications to a protein or patterns of modifications to a protein. And that's best done by top-down proteomics. One of the things we want to understand is there are cardiomyocytes of different size, ranging from 40 microns to 100 microns. And we want to understand, are there biological differences between the sizes of the cardiomyocytes? And those sizes may, in fact, change as a function of where they're located in the ventricle of the heart. And so now we can look at not only normal hearts, but start looking at diseased hearts and see how the phosphorylation patterns might change as a function of disease. And there have been some studies which have been done on not single cells in cardiomyocytes, but on bulk cells. And they have seen that there are indeed changes in phosphorylation patterns as a function of heart failure. And so trying to understand what drives that can help us think about new therapies.